It's a laugh.
Okay, guys, welcome to the compiler hangout. We are here with both Chow and Adam, and I like to start as usual with some announcements, especially project, I guess, which is going to be due very soon. I hope all of you are progressing well and getting your doubts and other things um, clarified, and I hope the semantic analysis and IR code generation is where you should be now, and testing and finishing some of these things. The tree walking and all those things I hope are very clear, and the examples in the book are helping you. So if you're behind, immediately you need to catch up using this weekend and not really get behind more and clarify any problems you might be facing. Um, the TA, I just discussed some things with TAs. They're going to put some addendum in terms of exact form of deliverables, formats, etc. And they have already clarified the type compatibility semantics issues, which there was a little bit confusion about. They will also make sure that is there in the addendum. So you will find everything in one place. But the clarification they have provided in terms of strict name type equivalence is the one which you should go by in terms of type enforcement. And please follow that in terms of semantic equivalences and semantic checking. So as far as the homework is concerned, I hope all of you are again doing well on the homework 2, which is about parsing and attribute grammars and so on, which will give you a nice theoretical overview of how things will work in terms of automated techniques such as semantic analysis using attribute grammars. One important note here is that those techniques are not followed in practice because um, attribute grammars lead to a lot of overheads, but they're extremely good for understanding because that's how the attributes are combined, are propagated as parsing takes place, and then compared with expected attributes such as types, expected types, and derived types. And any mismatches there are reported as type incompatibilities. The reason they are not automated is because of huge amount of overhead that is encountered in transmitting it. So some of the tree walking things that you guys are doing, we will actually carry out the same process, but we'll have much lower overheads, and that is what is being done. In terms of LL1 grammars, there were some questions which we clarified in terms of the complexity, etc. Hopefully, all of you are able to practice some of this and understand the concept very clearly. It is one of the most efficient parsers with low complexity. Sorry, I have some cough today. But so I hope you practice it through examples and also derive the complexity using what we have asked you. And I hope you are chugging along further nicely in terms of future lessons, in terms of the IR code generation, and uh, the next lesson set of lessons talk about generating the control flow graph, and that is where the intermediate form gets translated from there onwards, so through the generation of control flow graph, liveness analysis, register allocation, instruction selection. All these leads to generation of the code. So these next few lessons are very vital for their understanding. We'll be doing homework there, and also the backend project, which is phase 2 of the project, will be assigned based on these. So we'll get to practice this on paper and understand them well, and also then implement them in your compiler. That's what is coming up in the phase 2. In terms of grading, I'll let TAs chime in terms of, I believe we have already finished grading of homework 1, and then homework 2, as soon as we get it, we'll turn it back up to you quickly. I know that the drop date is June 29th. By that time, I think homework 1, homework 2 will be turned back, and maybe the project 1, or at least some feedback we might be able to give you, if not actual grades, if you guys need it. And I'll let the TAs speak more about that. And that's all I have for now. And I guess one question for TAs is, when is our project phase 1 due, and how much time we have between that and 29th?
I think it's during 22, since I agree a week.
22nd, can it be?
Yes.
Okay, so we have about 7 days. Not sure if we'll be able to finish the grading, but those of you who are a little iffy about their project performance can get in touch with the TA, and then they can give you some informal feedback in terms of where they stand on the project side.
I
But
I thought the project was due June 20th. That's what it says on the paper.
20th?
Let me double check.
Yes, it's the 20th on Canvas.
Okay, so we have about 9 days. So let us see if we can at least give some feedback, maybe about test cases and things like that. I don't know if we'll be able to finish off grading. Do you think you guys might be able to turn it around back by 29th, which is sort of their drop date? Okay, so let's keep it this way. We'll make our best effort to see if we can give it back. Otherwise, we will try to. Those who have some iffiness, they can get in touch with the TAs, and we can give you some informal feedback of their project, how far it is from, how many test cases are going through, and what not, those kinds of things. Um, but homework 1 and homework 2 will be there. And if you have any general questions, if you're understanding concepts, and if you're planning things well, you shouldn't have a problem. If you are lagging behind, I really again and again encourage you to get back on track, because that I have seen as the most uh, um, biggest reason for somebody to perform less than their potential in this class, and then things snowball. So please don't fall behind. I think you should be good if you are able to keep in on a good schedule and get your questions and other things resolved. So that's what I have to say about your performance before the cutoff, the date. Other than that, I don't have anything else. Are there any questions for those who are here, or are there any things which we should visit, Chow or Adam?
Um,
No.
this is Frank. I have a list of questions actually.
Go ahead.
If that's fine to ask now.
Go ahead, Frank.
All right, sure. Yeah, so yeah, in regards to the project, so when we find a semantic error, do we continue or do we just print out the error and then stop the program?
You can just print semantic error and not continue, because what will really happen in so unlike syntactic errors, which are sort of detected, the semantic errors have a cascading effect, because if you, for example, a plus b is incompatible, then obviously we don't know what the type of that is going to be, and when it combined with c, that is also a semantic error, and so on. So they have a cascade effect. So typically you can print the first error and just stop and quit, and then go
Okay.
back and ask the user to fix it. There are semantic errors which are related to scoping. For example, if you have missed closing parenthesis, you've seen in compiler that creates a huge havoc in terms of which scope I should be using, and that leads to, in fact, some compiler errors. So it is best to just flag one and then quit.
Okay. Cause compiler errors and better to just quit. All right, great. So yeah, and in regards to the project, is there any way we could get more code samples then the 5 provided.
In terms of test cases, you mean?
Yep.
So here is how I suggest you generate some of your test cases also, and this is another thing which we have done in past. So I will ask the TAs to see if they can provide some more, but I think what might work well is if each team can also contribute a nice big test case, which is sort of covering different things. As you can see, we have different things to stress here. One is in terms of, hey, have I implemented scoping properly? Have I implemented type compatibility properly? I have implemented arrays properly. All these different things. So TAs, can you also ask each team to contribute a large big test cases, so that way we'll have a nice pool, and we'll see from our end if we can put one. The easier way to construct a test case would be to actually, if your grammar is correct, would be to use that to in fact generate a program. Those of you who want to experiment with that can easily do so by, instead of parsing, you put out one name, and sometimes it will lead to a sound program, which might have, of course, all the names declared. Sometimes it might lead to an unsound program in which you put out a name in an assignment statement which was not even declared, so it will catch some semantics errors. So in either case, you'll be able to exercise different parts of this. So this is one strategy I recommend, and there might be an Antler small utility to actually generate programs using the grammars instead of checking programs. So that is one thing, and contributing one per team would really help everybody to, and you can put it out on Piazza and share it. I think that will work well.
Okay. So I'm sorry. So you said to generate the code, so like compile the Tiger program and try running the Tiger file?
No,
Is that what you're saying?
yeah, what I was saying was, you have a Tiger grammar, and let's say we want to start generating the program in terms of expansion. So for example, you have a main, and then inside that you have an assignment statement. Okay, so use the rule, and the variable name should be um, generated, for example, like ABC, for example, and keep generating the names in the program for IDs, uh, including as a part of the declarative statements and so on. Pick the types, either int or float. So as you go through the grammar, instead of, so pick a random rule, um, use the rule and generate the names and populate those, and um, so that's how you actually can use the grammar to generate a program, a Tiger program. So that will be a test case, because when you actually run it back into through your compiler, which is going to do all the syntactic analysis and etc., it will pass the syntax analysis, but it will fail in terms of, um, um, for example, semantics, because it may not have some variable declared, it may not have compatible variables, things like that. So that is one way to exercise semantic analysis phase. And then as you generate, for example, an assignment statement, you can randomly drop off something. Like, for example, you drop off an operator, so it will lead to, of course, syntactically invalid statement. You can drop off maybe a assignment operator that may lead to a wrong assignment statement, things like that. If you drop off a closing parenthesis, that will lead to syntax error. So that is what I was mentioning.
Okay. So yeah, just to clarify, so you're saying in Antler there's like methods we can use to actually generate the Tiger code, and
So
that's a good way.
yeah, so there may be, but or you might have to actually do it using the grammar, as the grammar is parsed by the LL1 parser. Actually, you, instead of matching, you actually output the variable names and so on.
Instead of matching, we output the variable names. Okay.
Like, you pick one rule, right? And you started going through LL1 parser. so here is how it will work. So you'll pick maybe the first start rule symbol of the grammar, and you will go to its right hand side. And wherever there is ID, if you encounter an ID, you will output a random name there. Okay. If it's a keyword, you will keep it the way it is, and you will generate it. So as you will get into, for example, a main and the body of the main, that's where you will pick maybe the first is some kind of a declarative statement like int a int. It will start with int and then follow that with list of IDs, and the IDs names could be generated randomly.
Generated randomly. Okay.
In the
Um,
sense, the first name could be AB and the second one could be something else. So you are generating a list of variables randomly, and that will lead to, if you keep doing this, you will see that if you go to an assignment statement, maybe something else will get generated, CD, which is an undeclared variable. And then when you feed this kind of a program, uh, you will be able to catch the semantic errors.
okay.
It sounds a little complicated than just write it by hand, I would say. But this is an automated way of exactly using the parser for generating programs in a reverse way.
Okay.
Does that kind of make sense?
Yeah, I mean, yeah, it makes sense on like the concept.
Mm.
But I
How
don't
to
know
do it?
how to do that in practice with the
Right.
parser, I guess.
It would be a lot of work, I think, especially
Okay.
since we're in the last, we're in the last 7 days of the project lifespan. When I completed this, I really just like if I were struggling to understand the while loop, because the Tiger syntax is kind of weird, right? If you're used to other languages, so I would just write a test case that did a while loop and see if the output made sense. The other thing that usually confused me was the let blocks. I didn't understand why this concept existed. But if you start trying to write, a real program in Tiger, then things start making sense. Uh, it generated this IR because I used a let block right here, or I had a nested let block, or whatever. So I wound up with I don't know, 5 or 6 test cases that were published, uh, as part of the course, as part of the project. And then I think I wrote maybe 10 more. I wrote some that were supposed to fail syntactically, some that were supposed to fail semantically. Um, I wrote some that had scoping issues, um, and it actually helped me understand how the language is supposed to work, kind of overall. Anyway, so it was useful.
Okay. Yeah, okay. So it sounds like it's probably just easier to make our own Tiger samples then.
Yeah, I agree. Actually, I have created a separate thread for you guys to share the test cases. It seems like nobody has responded.
Oh,
Yeah.
yes, yes. The Piazza post? Yeah, I remember that.
Yeah.
Yeah. Okay. Sure. All right. So yeah, I guess moving on to my next question then. So yeah, so in regards to the IRR code generation, um, is there any is that is there anything from Antler that we can use to do IRR code generation, or is that all going to be implemented by us using like the tree walk?
I would
Oh,
think it's going to be implemented by you.
Okay.
Yeah. So I think it only the Antler will only provide you hooks, and you got to put the code in there at the right places. It will provide you with the traversals, and the code generation has to be written by you. So, but you can follow some examples of maybe which are there for small languages, for which there might be some code generators and semantic checkers to see how they are doing it. But pretty much you have to do it.
Okay. All right. Just want to double check that. Okay. And so in regards to the error code generation, so all we have to do is for the scanner, we just print out the error that Antler's throwing us. Um, and the same thing goes for the parser. Um, and the semantic errors is shown. The project doc shows an example of that. So the only error that we have to properly format is the semantic error. Is that right? I put the error into the chat as well.
Yeah. Other
Okay.
two errors are coming out of Antler, actually.
Okay.
Unexpected token var of type var. This is so unexpected token. That's one of the actual Lexer errors that's thrown by Antler itself.
Okay.
I know one thing that Antler allows you to do is override the. I'm pulling up my project to see. I can't remember what they call it. there's an exception method, at least in the Java version. There must be in the C++ too. You can create your own class that represents a tokenization error, and you just have to.
Okay. Yeah, we have our own error listener class. I don't know if that's.
Yeah, that's what. Okay, it was the syntax error listener.
Okay. All right, but we don't have to do that. We just.
I don't think you have to. I'm trying to remember why I did, and there was some reason. I think it helped with something. But I mean, if you're, as far as I know, if you're just outputting your semantic or your syntactic errors just the way Antler wants to in the first place, I believe that's all you need to do.
Okay.
Could be because I remember actually reading the project spec, and it was saying you need to report scanner errors or lexicographical errors, and I just remember thinking, well, wait, do I even have to do anything? Because Antler kind of does that for me. I get that for free.
Right.
And it also automatically does a token reset too. So if it encounters a token error, well, it just reports it and then just skips ahead to the next valid token that it can resolve, keeps on going. So I believe Antler just out of the box does exactly what you need for reporting syntax errors. But then the semantic errors are where it's up to you to kind of format how you want those errors to look. It's up to you to write the code that actually figures out what a semantic error actually is.
Right. Okay. All right. Sounds good. And so I did post a question on this, and I just wanted to make sure. I wanted to just double check because so and I'll post the Piazza question in chat. It's regarding the error output as well. And it was I think Chow responded. It is acceptable to not have to print out the word assign. And I just want to make sure that's what it's saying, right? So instead of saying assign, just have colon equal, and then point to colon equal.
Oh yeah, that should be fine. I mean, as long as you're pointing to the error and sort of giving the user enough feedback. So we won't be too sacrosanct on exact prescription because it's a part of user feedback design, and as long as it prompts, imagine you in the user's shoes or a programmer's shoes who is getting this from a compiler, so it should help me remedy my error where it is and so on. So I think as long as it points to the right place, right token, we should be good.
Okay. All right. Well, so that's not the error part. That's just the output part.
Yeah.
Okay. All right. Sounds good. Yeah, I just wanted to make sure.
And Chow can please correct me if I'm wrong, but I don't get the impression that any of this project is auto graded. So if you like, I don't think there's an exact output that we're looking for. I think, and again, Chow, please correct me if I'm wrong. Tell me to shut up if I'm wrong.
Mhm.
Um, but I don't think if your semantic error says exactly this thing,
Right.
we're going to dock points. I think our test program will just provide a program that has a semantic error, and will expect to see some kind of error reported. And I think that's been a source of a little confusion too, because I know the IR, there is no quote unquote specification for the IR output other than the operand or the operations themselves, the opcodes. Um, Again, I think a lot of this is just informational, so that whoever's grading your output can at least make sense and see that, okay, yeah, the IR that came out of your compiler matches kind of what we're looking for, and it's got this header information that seems reasonable, and et cetera, et cetera.
Yes, you're right.
Yeah, so we are not, again, being extremely format oriented, and we are not using auto grading at all for this class. The specification for IR is a description of how it should look, but is not checked by any kind of automated means. This is to give some flexibility in terms of internal design decisions for students to innovate a little bit on the IR. They want to put a little bit of more information or less, definitely not less information, but anything more, and which will help you, of course, in terms of your design, in terms of carrying values from front to back end. And you can mention that in the report, and we will look at that in terms of what assumptions or additional annotations or anything that you are making there. And that's why there's no auto grading either, because we look at that particular report which comes along with the IR. And unlike other classes, this class is about concepts and some kind of decisions that are being made, and those should be documented. So that's what we will expect.
Okay. Okay. And so one last question about I know this is about the format, or well, so it's not. It's kind of about the format. It's about the temporaries. Um, so do we need to keep track of like special IDs for each temporary, like T1, T0, T2, or can we just call it all temporary?
So you have to distinguish the temporary names from the program variable names. That's first thing,
Okay.
and that's why there is some annotation there. And then typically the practice is to keep a counter and attach it to a name, a base level name such as underscore T, and it also gives you readability. Um, you can of course call it underscore temp, but that becomes a longer string, and so on. And the first underscore really distinguishes the temporary. That is important, so that it doesn't mangle the original program namespace. So that is really the important part. And then numbering them is the easiest way of generating them rather than random strings. And it also allows you to track what is going on in terms of, hey, this temporary is going to go from here to there. In terms of its use, it's easier to kind of even visually find out what is going on in the IR program without actually writing any parser or generating any AST or anything from it further. So I would recommend keeping the namespace distinct and simple, and use some counters. Um, Beyond that, of course, the name's choice is really yours.
Okay. All right. Sounds good. Okay, I think that's it for me. Yeah, thank you all for that.
Yeah, great.
Sure thing.
Thanks for the question. I think it's helpful for everybody. So thanks for raising the questions, and hopefully everybody benefits. Again, going back to test cases, I would like to emphasize that let's ask each team to contribute one large test space, and in future we'll automate the process of generating the test cases, maybe through a bonus kind of route. But maybe this is a little too late for that. I agree with Adam. It's not extremely difficult, but you guys are doing a lot of other stuff, and this project is due very soon. So maybe once you finish the project, somebody can volunteer and contribute, or I'll probably ask Chow and Adam to write a simple program generator. And such test cases are, by the way, used a lot, automatically generated in finding bugs in compilers, just to mention it. So GCC, believe it or not, has lots of bugs. And I'll ask Adam or Chow to post an interesting article on the bugs, or I'll post it once I look it up. In GCC, it is not exercising parser. It is not. Most of the bugs will be found in the semantic analysis side of the house, and occasionally in the not in the syntax side, but semantic and IR code generation sides, or even sometimes backend side, which are very hard, of course, because they are not based on the namespace of the program, and they are. But they generate lots of test cases automatically. You have to generate, because manually, if you generate it, you can see that you may not exercise those parts of the compiler. So that's why this automated test generation is important. Sometimes the automation of test cases is generated is done at the IR level, which is actually a little easier also, because quad statements you can randomly intermingle and see if what effect it has on the backend. Of course, the IR has to be sound. In other words, one can easily see that the compiler does assume that the IR is semantically right, and so on. So that becomes tricky to keep it valid. So sometimes the test case generation, but in rare cases, just moves around the IR statements and see what happens. If generated code should crash, of course, in some cases. In other cases, maybe the compiler will catch it. We'll do another analysis of the IR and find out if it was sound or not. To in fact, before it lowering it into the backend further. So, but most of the test cases are at the source level. Just as a closing thought. All right, guys. Any other questions or any other issue that we need to discuss, or any other questions for those who are on the Hangout? If not, I guess I'm going to mute, because I was doing something here, and then check back in a little while. We are almost actually getting towards the end, but I'll mute myself right now.
Okay. Yeah, great. Thanks. I'm gonna drop off now. Appreciate it.
Thank you, Frank. Thanks for coming over.
Hey, Chow, are you still there?
Yes.
I had a quick question about the type equivalence addendum.
Mhm.
Here we go. So if type equivalence is by name only, that does not apply to int literals or float literals, right? So I can make a new type, my int type, that is an integer, and I can still initialize that using some int literal. Is
Yes.
that correct? Okay.
Yeah.
Just wanted to double check.
Actually, when we do working on the new specifications, we traditionally became allowing the type of registration just between float and int. I mean, you can float the int to hoist the int type to float when they do the binary computations. But we can restrict like if you the registration among the my int and the float. No.
Oh, so you're saying that my int type can still operate against the int primitive, and my float type can operate against the float primitive.
No, I mean the int can still be operated with the float because in that case the int will be proportional to the float and the result is the float. But the my int potentially cannot be promoted to float. At the same time, my int cannot be added to int.
Okay. I might let me forward you what I'm writing up. I had a hard time hearing what you were saying. There's somebody's like chopping down a tree right next to my house.
Okay.
I'll just send you what I'm writing out, and you can check because I'm putting code samples in here too, just to demonstrate what would be okay and what would be a semantic error.
Okay, no problem. Okay, let's stop here today. There's no more questions.
Yep. Alrighty.
See you next week.
See ya.